just a rebranding. The project is already like 5 years old, I think. Oh, yeah. It's quite old already, this project.
5 years. But was React?
It was React RB, and then even the Hyperloop for React, I saw the history is about 5 years ago. 5 years ago. Do you like React? Do you like React? Yes. I like React. But I don't like the work with JavaScript. You know, I don't do front end, so I'm not familiar with React. It's a very nice way of doing it. Okay.
Okay, so this is the art of tracking, or when a pixel is in the pixel. So I'm Tristan, I work at Mindvalley, so that's the company t-shirt, I have it. And this is a quick story of how this came about. We were working on something, a project called Blink, where it shows you a masterclass. So basically you have this website, you click on watch now, you see a masterclass, right? And before, this was handled by a third party on a different website, and we were saying, okay, the new feature is that you actually watch it inside the members only page. So you have to log in and those things, and it's a lot easier because if you're already inside the application, you don't have to go outside the application, sign up again. So it reduces a lot of the friction. And one of the things that we needed to implement, aside from the actual functionality, was a tracking pixel where it should fire and record whether a person actually finished through the whole purchase process. So basically, someone signs up, watches a master class, maybe hopefully clicks on the link to buy and then buys it. So marketing wanted to find out whether people were actually buying from this particular variation or from the original version. So we were doing the A/B testing. And I found out that the team actually has no idea what the tracking pixel is. They just know that Google puts it there, but to actually implement it, how it actually works, they didn't know how to do that. And I'm not sure if any of you actually know how tracking pixels actually work. So, and I said, this is actually interesting. I don't know if it's a generation thing, a generation gap that we used to do our own pixel trackers. There used to be lots of like Ever cookies and those things. Like it was like the holy grail of trackers where you can never delete that particular tracker. And then that got sued, and then now we have GDPR and all of these things. So it's a forgotten craft, but I'd like to revisit that as well. And at the same time, I'd like to also delve down into how the underlying technologies work that make these things possible. So the joke is a bit hard to read, but it's not really related to HTTP. I just thought it's interesting because HTTP is on top of TCP. You'll find that there's a lot of repetition, and that's actually the thing about TCPs. Like the sender says hello, howdy, I've heard everything you've said up to hello, and the server replies, I've heard everything you've said up to howdy, which is exact. If you do Wireshark, I didn't have enough time to get the capture. This is exactly what's happening over TCP. TCP, by the way, is stateful protocol, and we'll talk about that. I'd like to run this quickly. I think I can go to a different. Am I just casting a tab? I am casting a tab. Wait, sorry. I'll just cast the whole screen. How do I go back? To cast the whole screen?
Did you touch desktop?
No, I casted the tab.
You have to close the screen and
no!
Go back. Yeah, go back. And the back button. Click on play. No, you have to go to the back. No,
go back.
Go back. Then
Cast.
click the back button.
Yeah. Okay.
There's a drop down here.
Yeah, desktop. Okay.
Yeah. Then
cast. All right.
Yeah. Okay.
Best
Wow.
Yes, best UX.
Okay. Yay, okay, I will go quickly. So I'll show you behind the scenes how HTTP actually works using Telnet. I don't know if you remember Telnet. This used to be the tool we used to test sockets. If you've ever actually done sockets, I don't know. Old guy talking. So this is actually how you do it. So everything here that you're typing is actually what is being sent by the browser automatically, right? The syntax get, I think, slash the path, HTTP slash and the protocol, the version number, the protocol and the version number, which is 1.1. And then, yeah, right. No? what did I put? I forgot already. Wait. Yeah, the host header. You're right. The host, which is www.google.com. Is it the colon? Oh yeah, you're right. Yeah. Okay. You remember?
Yeah.
Okay.
Oh! I won't admit how many times I did it.
No, go back. We try. We try. We try.
No, so if you use Netcat, then you get a lot more.
I was practicing this and now I'm making mistakes anyway. HTTP/1.1 and then you type host www.google.com and then the specification says you have 2 carriage returns and you have to press enter again. And now you have the response, right? This is the Google homepage, by the way. You'll get an HTTP 1.1 200 OK. This is exactly what goes through the wire. I wanted to put a Wireshark capture, but I didn't have time to do that. You have all cache controls, you have your set cookies, and then of course you have your page content. So these are all the what's called HTTP headers, and then you have all of these things. So I put it on a screenshot as well for you. And I'm not going to run the presentation again because it will take some time. All right, so this is what goes through the wire. And you might, I've already mentioned that HTTP is a stateless protocol. It's not really related to functional components for the React people here, but it has some similarities. So it means that, so in React, for example, if it's stateless, you don't have anything saved. It's the same instance everywhere else. So basically, it's a lot easier to copy things in memory because it's basically the same thing. You're just changing the parameters. Similar to how you would think of HTTP, there's no record on the server that's being kept. When I ask Jimmy what time is it, it doesn't know that when I ask him again what time is it, that I'm the same person. It's a very, very short-term memory. Like he doesn't have to care. Like anyone can ask, and he will always ask the same question. It's the same, similar to how UDP protocol will work. It will keep on. It does not retain any information about the sender aside from what it needs to do its work. Okay. And so the advantages here is that the server, from the server point of view, or the implementation side, you don't have to waste time or resources maintaining synchronization logic. So the server, for example, can just copy the same information everywhere else, which is what content delivery networks are doing. It just copies everything else as is because it doesn't have to care about logic. It doesn't have to have application logic in it in order to serve a request. It's great for intermittent connections as well because, for example, if I disconnect, I connect again, the server doesn't care and doesn't have to maintain state about is it the same person that's connecting. The client is the one. So the onus is on the client to maintain the connection state. So I can say, okay, the server can maybe send me a token, and then every time I send a request to that server, I send a token as well so that the server knows that I'm the same person or I'm the same client. So basically the transfer of ownership of state happens on the client. CD to cache, like I said, the CDN, content delivery networks, proxies like Squid, or the ones that Redis caches, for example, they store the information as is, they replicate the connection because you don't have to replicate application logic. It's like and you've seen here, if you've seen the movie 50 First Dates, basically that's what's happening every day. So every day is a new thing, you have to start reintroducing yourself, everything else. There are different ways to maintain state. The classic way of doing it before was with URL parameters. So every time you have to say, okay, I want to get this resource and this is my username, you tag that into the end of the URL. Let's say /profile $name equals Tristan. And then for every request, or token equals whatever, and then for every request you send it, and then the server will just parse whatever token that is, find out the information related to that particular token, and then you send it back. You can do IP binding. This is like even more old school, remembers the IP and considers that every request coming from that IP is the same client. And so if you have like a whole network, for example, in a NAT, and then you ask a server, the server thinks that every computer asking through that NAT or network address translation router is the same client. So those are issues. Hidden form fields is something interesting as well. The Rails CSRF functions similar to this. Basically, the browser will render a parameter inside your form fields, and then it will consider the same. It will consider the client as the same client if you're sending that form field back. So the server will know, okay, I sent this client this token, I will get it back. It's similar to how URL parameters are working, but as hidden form fields. And of course, cookies. Cookies are like small pieces of information that the browser will send over and over for every request. And this is actually the primary technology behind pixels. The fact that each cookie that is saved under a domain is being sent with every request made to a server. Okay? If you don't believe me, you can. I will show you on the demo later how that actually works. So these are just a few sections which I will talk about later as well. This is the Ruby implementation of the classic pixel tracker. So the pixel.png, and then I will show you that the query string is being sent, and I can actually capture cookies for even if it was requesting a PNG. Now you'll see that I'm not actually getting a file. I'm just doing a base64. This is just because it's a 1x1 pixel. It's a small thing. I don't have to actually read it from the database. This also makes it easier for understanding that this is not an actual image. So it's a classic pixel tracker, and that's where it got its name, is because the way you would implement the pixel tracker is through a pixel, like a 1x1 transparent GIF or PNG pixel.
It's a valid pixel.
It is a valid pixel. It is. It's a base64 encoded pixel sent in binary image slash PNG. It is a real, yeah, it is. It is a real image. Although the next technique I'll show you is not an image. It's a pixel tracker, but it's actually doing an iframe. So that's when I'm saying that pixel is not really a pixel, because people say this is a pixel tracker, and everywhere else in marketing they say, oh, I need a pixel tracker here. But sometimes you're not really rendering a pixel. Most of the time you're rendering an iframe, which then runs a piece of JavaScript that calls back somewhere else and says, okay, this person has purchased your product, right? And this is, for all intents and purposes, it does the same functionality. The way it does it is just different, right? So now you have your, I'll show you later how this actually works. Actually, I'll show it to you now. Where is it? Okay, this is the code. You'll see here that it's a very short file. It's really just rendering two of the techniques. One is the pixel tracker. One is the iframe tracker. It's just using Sinatra because you don't need the whole Rails thing to do this demo. And I will show you, I want a 2-column layout with index here. And I show you here that first one is rendering an image, normal image. Second one is rendering an iframe. And usually you say displays none because you don't want your content suddenly shifting because you have an iframe there, right? So let's visit the 4, 5, what's the port? 4, 5, 6, 7. All right, yes, now it's the image is not working. Anyway, it's Windows. It was working on Ubuntu. Oh, what happened? No, apparently I have a... What? I don't know. It was working 14 days ago.
Pixel base 64, not pixel. The variable is pixel underscore base 64.
Yeah, you're right. Okay, there you go. Yes, all right. I'll try it again. I'll clear the console. All right, right. So you'll see here that let's start first with the classic pixel tracker. So the classic pixel tracker is also done server side. And what happens is that there are no cookies right now on my on localhost. But if, for example, let's see, do I have cookies? I have some cookies here. I can, yeah, I can. Well, this one is not. I might have enabled some privacy related things.
Just do the incognito.
Do you have cookies just now, you said?
Yeah, I have cookies. Like I have some on localhost tests, but it's not sending it right now. But probably some. But yeah, but it will show you some cookies. And this is running on the server side, so it actually has to read what the browser sent you, and it will process it on the server side. And the problem with pixel trackers, this classic way of doing it, is because it happens on the server side, the server will be processing a lot of these requests. And if you're not careful, your server will be blocking at that particular request. Like if the way you process it, if you have to save it into the database first or whatever, it will block at that point, and the request will not return to the client, and the person will wait for some time with that spinning thing. If the request doesn't finish in time as well, let's say, for example, you have to save the tracker on a redirect and then on an intermission screen in order to go to the thank you page of your website in order to trigger payment completed, it might even give you wrong stats because the request did not complete, you never save the information, and then when the person has already finished the payment, you never recorded it. So that is a big problem here, which is why they go for the iframe. So in this case, the iframe, you'll see here, again, the cookies are not actually being sent. I did a console log because iframes, they are just mini web browsers inside a page, which is a valid web browser, and it actually will run JavaScript that you ask it to run. And in this case, what I said is that it will say hello world, it will pass you the query string, and then the request cookies will be also logged in. You'll see here, request cookies is actually the request that got into the server. I'm just passing it through blindly so that you can see it here on the console and show that it's actual JavaScript. The issue here is that if you do JavaScript like this, remember this is executing on the browser, and not a lot of browsers are ES6 compliant. That means you have to do ES5 and code it by hand. You don't have the modern quality of life stuff like Babel and Webpack, which you can do all of these what's the fat arrow function stuff. Browsers don't understand that right now. You don't have module imports, for example, all of these things. So you have to write ES5 compliant code. So that's the only thing there. Plus, later on, you'll see that it might have some issues with same origin policies and CORS. So because you're actually running on the browser environment and not on the server-side environment, well, usually you can do anything you can. All right, let's go back to the presentation. Is everything clear on the demo, or do you have any questions on how the whole technique actually works? So basically, you get that image. So if you have this particular file, this HTML will usually be your thank you page. And whenever this thank you page is so usually the steps here would be when someone signs up, you save a cookie on that domain. And then when you go to the thank you page after the person buys, you embed the tracking pixels and send in the same cookies that you've set on the sign up page. Because that means that you can track the performance of that sign up page, what's the return on investment for people who sign up there. If you're driving traffic to that page, you can track how many people are actually buying because they signed up for this particular page. That's usually the marketing point of view there. All right. let's talk a little bit about CORS. If you've seen this before, no access control, allow origin, and those things. Like in the backend, we're always used to just being able to capture any kind of information we want, because we just open a socket, we get all of the byte streams there, and then we save it. In JavaScript, you're not always allowed to do that. When you do an AJAX request or a socket request to a different website, it depends if they have added CORS policies on that particular page. And that's generally because of, again, the cookies being sent for every request. So browsers implement this thing called same origin policy, where JavaScript can only access information if it's from the same origin. So if you're, for example, you embed JavaScript on your page, like Google's, what's their ad tracking thing? No, Google Tag Manager is something, yeah. So if, for example, if you embed Google Tag Manager on your page, that Google Tag Manager is considered to have the same origin as your web page, and then you can do that. So the problem there is that if, for example, Google turns bad and then for example, is able to access your bank accounts, for example, and because remember, whenever your browser sends information, it always sends the cookies. Then Google will be able, if it pretends that it comes from the origin of that bank, it will get your session cookies, and then will be able to log in to your bank using the same cookies. I was able to like copy cookies, for example, and then send the same cookies and then masquerade as a different person. I think before Facebook implemented HTTPS only login, so Facebook is now only HTTPS. There was, I think, Firesheep. It's called Firesheep. Yeah. So Firesheep allows you to watch the network. Yeah, this one. It doesn't work anymore, but for HTTP, and this is the reason why HTTPS is very, very important, because on a network, on a LAN, for example, everyone's traffic is visible to everyone else. And especially, for example, on open Wi-Fi, you can connect open Wi-Fi, everyone's traffic is visible to you, and Firesheep, it's just automation. Basically, you can see someone's logging into Facebook, I can see the same protocol, the same information as people, as I've seen you. This is in plain text because it's non-HTTPS. I can see, oh, someone just set a session cookie for you. I can get that and use that to log into your Facebook.
That's a simplification, not only on open Wi-Fi, all the way along the
yes. No, but that's the
everybody can see it.
Yeah.
Like your grandma can see what you're
correct. Exactly. And if you don't believe all of these like ads saying VPN, use VPN software, use HTTPS, it's because you're probably not aware of it. But yes, if you're using an unencrypted connection, the way infrastructure is set up, everyone is able to see what it is that you're browsing. And so that's one of the reasons why you should always use a VPN or do not connect to open Wi-Fi stuff. But the open Wi-Fi and Firesheep, it's just it changed the perception of these things. It's not the only
it made it
angle.
easier.
Yeah, it made it easier.
Correct.
Yeah.
Yeah.
And people became aware. I don't know if you were aware, but more technical people became aware. This is actually a big thing, and so that's why HTTPS
Before
became.
Before that, HTTPS on Facebook is optional.
Yeah, it was optional, and so that's something. So you should start using VPN. All right, so these are how cookies. I think I misordered the thing. Cookies are always sent for every request. This is how they look like. You have your domain and those things. You have session cookies and you have persistent cookies, depending on when they should be deleted. There are other ways to track. For example, it's not only cookies that are being sent. Browsers will send also the identification of your browser. Let's say, let's do something. Let's have the network. So for example, on Pixel, right? It sends you a lot of these things. Your request headers, for example, will always say, what languages do I accept? It will say, what's the user agent? And it's not always the same for every person. Like a browser, I'm using Chrome Canary, for example, so this is different from normal Chrome, from Chromium, from Firefox, from the phone thing. And the way browser fingerprinting works is that because your browser is probably unique, it will create a fingerprint of your browser, and every time this same fingerprint happens, I know you're the same person. So even though I have no cookies or whatever, I go to incognito, it's because my browser is the same, has the same fingerprint, then it will know that I'm the same person that was browsing a different site from before. So there is this thing called Panopticlick from EFF. You can test me, and then it will show you the different types of information that this browser is sending. I'm not apparently protected from browser fingerprinting. I've already done it. I will go to the next. Okay, it's fine. Show full results. This is just an advertisement, but this is what's important. So it actually says that I'm unique among 2 million plus tested in the FAST45. So it's 1 in 2 million that I'm a different browser. It's not the whole thing because you have billions of different combinations, but it's a generally good guess that I have.
Frame to request for the same
yeah, that I can be identified like this. So because of this particular fingerprint, this is what my browser is sending the server. And so it does browser plugins, time zone, do not track header enabled. It's true, but I'm still being tracked, right? Because DNT is actually optional for servers. You can set it, and then you have a hint. Yeah, it's a passive aggressive request like, please do not track me. But up to you. You can track me if you want, but I prefer not to. So that's basically what it means. System fonts, a lot of things are being said. There's another thing called the EverCookie. If you were doing web development in the like almost a decade ago, right? This is an API where even if you clear your cookies, there's a lot of different ways where it will regenerate those cookies. So it even stores it in Flash, in the Flash plugin. Yeah.
I think it's storage.
Yeah, well, because Flash had a storage thing before, and then it's the same for every browser in your system because the same Flash plugin, right? And so it stores it. Even if you change browsers, you are still having the same cookie from the Flash. That was different. E-tags are a way for a hint for caching, for example. That's why you have your 304s and those things saying that I have the same content. You can embed some information in e-tags as well. There's a lot of things. There used to be a way for CSS cache classes. Remember when your links?
We forgot about the e-tags one. You can do training
With what? Sorry?
E-tags.
E-tags?
Yeah, I forgot about that.
Yeah, e-tags. So the CSS visited links used to be how you would save it. If this was already visited, the browser changes a class, and you can observe the change in the class because it's a different color now, and then you know, okay, this person's already visited before. So there's a lot of things, different ways, and then all of them are active, and if one of them was removed, the others replace it again. So that's why it's called a never cookie. So there's a lot of interesting stuff there on tracking. But I'd like to come to like a conclusion when this happened during that particular implementation, right? Like I was surprised that the team didn't know about it, and we do a lot of front-end stuff. We do a lot of very complicated JavaScript with all of these reactive stuff and things changing all of the time. But I feel that what we were doing when it's really high level, but we keep on forgetting to go back and find out what are the fundamentals of this technology that we're working with. Like what we are working on the web, at least for those of us that are working on the web or on JavaScript, but what does it mean for HTTP to be stateless? Why are we using cookies? Why are there cookies in the first place? Why can't we just open a connection, a persistent connection like what we do in the past, and just open it, keep it there? Why did the creators of HTTP and the web, why did they decide this type of connection? And I think that's something that we need to start thinking about. It's like we have to go back. If you want to be a master of our craft, we have to go back to the basics, find out exactly how does this thing work. Because by going back to the basics, we start building on top of it again and having a different perspective to what we are doing. It might be, okay, we're doing a lot of reactive stuff on JavaScript, but why does it work, for example? You have observers probably, and how does it even become reactive? Like what you were doing with the console, for example, right? How does saving something on the database even affect what happens on the front end? And that's the kind of thinking that I think we should start going into again in order to become better developers. And yeah, that's me, again, Parasquid. I work at Mindvalley. And if you want some resources, I'll put this up on the Facebook group as well. The Panopticlick and the Ever cookies, and also some of the information that I used for this presentation. Thanks.
Any questions for Tristan? What's the chief problem solver?
Sorry?
What's the chief problem solver?
It's a cheap problem. I solve problems in the company.
It's a self-proclaimed
My card has it, so apparently it's official.
Yeah, it's a self-proclaimed, but turned into like official.
Is it still the trend now?
Huh?
Is it still the trend now?
Is there even a trend?
Well,
Chief problem
Facebook
solver?
has, like, do you remember the I'm CEO bitch?
Oh.
Like,
Okay.
I forgot the name of that Facebook founder, Zuckerberg.
Zuckerberg?
Oh my god.
Yeah. But he owns the business, so technically he can call whatever. Yeah.
No, but that used to be a trend in startups that you have a
Yeah. It is still, I guess, a trend.
Let me turn off my casting.
Let me cast. Well, there's nothing much cast. But I just guess. I guess I just want to. Oh wait. How do I do this? Shit. Okay. Right.
You're gonna show us your private session?
Okay. So that's all for the talk for today. So now it's Ruby tips time. So, any Ruby tips? Carlos,
Yes.
your Ruby tips?
Am I gonna break the display again?
Don't know. Let's see.
Let's try it. You broke this display though.
You what? Okay.
It's kind of mean.
Let's try HDMI on your Ubuntu server. That's.
So you need Chrome.
Oh yeah, you need Chrome.
Yeah, look at his face.
Can I run without?
You can switch
Do I have to run it?
You can switch the TV mode.
You mean this TV, is it?
Yeah, I think that's an input.
The cable?
Just use I think we just use the.
Oh wait, that's the PS4.
Yeah, let's borrow it. Yeah, let's borrow it.
So hold on.
Connected to PS4.
Oh shit!
This is the one.
Brain fart.
Wait, this is not. No wait, this is not. Wait, what is this?
Can you try this?
Can.
Just
Hold
plug
on.
into the speaker.
Oh wait, what is this?
Did you break the display again?
I'm about to. Give me a minute and it will be done.
Stefan, this HDMI connects to the projector as well, is it?
Yeah, you have to
Okay.
switch
I have to switch the projector.
the controller is on the PS4.
Oh.
That
I
is.
just used
No, that's
it.
the
Why
Samsung.
is there so much- I just used it. Why is there so much setup now?
I don't know.
I
I don't know.
It's like it still works.
You don't have Chrome, you don't
He has like weird setup for his screen resolution.
You know, I wiped off Ubuntu here and just installed Windows because of these problems.
What?
Okay, yeah.
Okay.
I tried to deal with all these things.
All right. So the first one is the what? Is it big enough?
Yes.
And it still fits on the screen, or?
It crossed a bit. Yeah.
Okay.
Yeah,
All right. So the first one is what I said on the previous talk is you can use an easy way if you have workers or things running on the server is you can set the program name variable. It's a global on Ruby, and that makes it so that when you do PS, the whatever you set shows up on the description of the process. So instead of saying GFS DE HTTP, it would say whatever you assigned it to. I used to work. I know a few things, and I've done this before for like workers. So if you have like Sidekick workers, it's a good way of knowing what your worker is doing, especially if it's processing a queue. You can have not only what is the worker, but also like what item it's processing, or if it's like mood step processing, which step it's doing. So you can have it like. If you were sending emails, you can say sending email for user X, and if you were processing multiple things, you can say exactly which step you are at. That makes troubleshooting super easy because that information becomes like readily available. Any server you go, you do PS, you can see like how many workers, what is the status of each one of them. The other thing is there is this. So if you have a list in an array in Ruby, you can use like .each .map and then just call something on it, right? So you can do, I don't know, name, and then you call like name on all the items of the list. The thing is, it works by calling item.name, but if you wanted to instead call something like I don't know, get name item, that's usually not possible. So you end up writing the full syntax of like .map item get name item. Then I found out, and don't pin me on the details because I already forgot why it works like that, but one way you can do this is by using like method.
I think you can't see it.
Oh, okay. Hold on.
Weird resolution.
That's fine. That's the easy problem.
Yes.
So if you have a function called greet that receives a name and then says like oi name, you can use method greet. So instead of doing what we had at the beginning, which is like what is greet, you would do method greet, and the reason it works is method is a function. So if you do method greet, it returns a function, a method object, and then I don't know exactly the details on the map, but then it executes that on each item instead, which is weird because I would expect it to call like item dot the function. Yeah. The function object that it returns, but somehow that's not what it does, and it works. So I just remember that. I just remember that if you do it like this, it does work, and it works the way you expect. I have it saved in a note, so every time I'm like, oh, how do I do that again? I just open my note and like, because it's really useful. The short syntax of just calling this is super nice because it's very concise, and the other one is not so much. So being able to do this is like I find it cool.
Can you string interpolate like greet the actual method name? So ampersand method colon something, right?
You mean here instead of greet?
Yeah.
Yeah. You can. If you have a variable like variable, and then it will work. It need to be a symbol.
Yes,
so.
yeah. I'm just saying that this is one of the things I might want to use. Like, save the name of the method.
The thing is, then it doesn't look that nice, but I think it's still nicer than the full version of the thing. True. So the thing about being nice is whether you recognize it easily, and sometimes at some level of noise, it becomes like less clear what you're trying to do. So
at a certain level, it becomes low code.
Yeah. And the one thing is that the map syntax is not bad. It's just big.
Yeah.
So once the alternative becomes as big as using the full map version, then it starts losing the.
Because typing out methods, bracket, everything seems to be unless you have like a really long.
If it's just method and you have the
symbol would be.
If you have greet, the difference between greet and method greet is not that much, so it ends up being fine. But if you start making it more complex, then I think it loses the benefit.
At least for new Ruby developers, like I didn't. At first, I was just using ampersand, colon, whatever, trying it out, and then okay, it's not ampersand colon, it's actually the ampersand that's it. Then colon is a symbol, right? Because it looks like a hash key and then value. It's not. It's actually the method you're transforming it into a call read.
I looked at what is the exact details of what makes it work, and then I forgot. Well, that's it. That's the tip.
Thank you.
Welcome. And I didn't break the projector this time.
Break the projector. Anybody else want to do? Okay. All right. If there is nobody else, you want to do? If there's nobody else, then that's the end of the meetup today. I guess just the final shout out for the what am I saying? For the Ruby conference. So be sure to buy the tickets and support them. The good folks at Sura Labs is organizing the whole thing. So kudos to them. So if you have any questions or anything you want to talk to them about, you want to throw a party for them, during Ruby conference. It is the thing. Like if you go to RubyKaigi, right? Every day during the conference, there are like 4 or 5 different companies throwing parties, like all over the count, just for RubyKaigi. So we should do the same.
I'll come for the party.
Yes. So that's it for today.
Which makes sense because if you're attending the conference, then you're probably on leave. This is a Thursday, Friday, right?
Yeah. So they get drunk. They get drunk, and most of them don't show up at the morning session, and they come in afternoon. So you see. Okay then. That's it for today. Thank you for coming, and see you guys next month. Bye bye.
Can I say something?
Yeah, sure.
Since we came here to connect with people, we're going to be on 3 days. Maybe I'm not sure if anyone is something to go for the beer after. Maybe we should go. I'll get to sponsor the first 2 giraffes.
What's that?
Giraffe, how do you call it?
Giraffe.
Beer tower. Beer tower.
Yeah. Oh, beer tower.
We call it giraffe in Spanish.
It is.
So if anyone has some
sorry, you're saying
like bar now?
Now?
Have some beer.
Anybody wants to go now?
We'll catch up with you. We just have a podcast.
Probably not able.
We're gonna do an interview now. If you want to interview.
No, I'm not. For the giraffe.
That's fine.
I'm probably not able to go. Yeah.
Where are we doing it? Okay, so if you have
Anyone else to join the
join the meetup.
You're close to me, right? So
we have a lot of time.
In Japanese, it's called left box.
Yeah, in Japanese it's traditionally called death gods, but yeah, we just call